Okay, so here we are now. Instead of simplifying an expression, now there's an equal sign in the problem. So now there's a variable, and we just do a quick little thing to solve for it. Okay, so first of all, you know what? I think I want to start with a different one. Here we go. All right. So when you are solving for a variable, the variable just stands for whatever it is you're looking for. Instead of saying, number of hamburgers that I ate on Tuesday, we just say V or H because we don't want to write all that out because that's lame. Okay, and we don't want to be here all day doing math, so we use a variable instead. Okay, so then when you're solving for a variable, there's the two questions you ask. Number one, what's being done to the variable? Well, it's being multiplied by 3. Negative 12 has nothing to do with the variable. It's on the other side of the equation. But the variable is being multiplied by 3. All right, that answers the first question. Second question is, well, what's the opposite of that? What's the opposite of multiplying by 3? Well, dividing by 3. So that's what you do. Because after all, 3 divided by 3 is just 1, as in one single v. And negative 12 divided by 3 is going to be negative 4. And the problem is done. So with every one of them, whether it's add, subtract, multiply, or just anything, you just, no matter how far you go in math, when they say solve the equation, you say, what's being done to the variable? Okay, it's being multiplied by 3. We're adding 2 to it or whatever. You say, all right, what's the opposite of that? And then do it. Let's try another one of these. Okay, so on this one, it doesn't matter. Okay, we've got this fraction here with a negative sign. You know what? It doesn't matter if the negative sign is out in front, or if it's on top, or if it's on the bottom. It doesn't matter. Okay. So I'm going to treat this negative sign like it's on the bottom. Okay. And I'm going to say, what's being done to the variable? Well, we're dividing it by negative 7. Oh, well, what's the opposite of dividing by negative 7? Well, I'm glad you asked. The opposite of dividing by negative 7 would be multiplying by negative 7. Now, notice I did not use an x for multiplication because that's already being used as a variable. And I don't want this to be any harder than it needs to be. Okay. So we've got negative 7 cancels with negative 7. And we just have x on the right side. On the left, we've got a negative times a negative. That's a positive. Okay, so ignore the signs now. And then 7 times 34, that'll be 210 plus 28. That's 238, I think. I certainly hope so. You know what? Maybe I should just hit solve. Yeah, 238. Okay, and so that's how it's done. Let's do one more of those, or at least examine one more. Okay, on this one, we're going to multiply both sides by negative 4 to get the w by itself, to get the variable by itself. We would multiply both sides by negative 4. On this one, we would divide by negative 5. On this one, we would multiply by negative 6, and so on. Okay, for each value of the variable, determine whether it is a solution to the equation or not. Well, we could solve this, but we haven't learned how to do it. Some of you might remember from years gone by, you would subtract 8, then you would divide by 3, but we'll get negative 10 for the answer. Oh, whoops, let the cat out of the bag. Okay, so is it a solution? All right, so remember, a solution to an equation is just some number that when you plug it in for the variable, the two sides equal. Okay, and that's just your basic definition of an equation and a good one to remember. So let's try 0. Okay, so does w equal 0? I don't know. I'll do it over here, I guess. So I'll plug 0 in for w. plus 8 equals negative 22. And I'm going to put a question mark over the equal sign to suggest this might equal this. Maybe, maybe not. And so sometimes it's overkill, but it's always a good idea to put parentheses around the number that you're plugging in. In this case, I'm plugging in 0. Next will be 7, and so on. All right, so the right side, there's nothing to do. It's just a number. The left side, there's multiplication, and there's addition, and we know multiplication comes first. So 3 times 0 is 0. And 0 plus 8 is 8. And we can say, no, they do not equal. All right. So let's try the next one. How about 7? All right. So we'll plug in 7. See if that works for the variable. Yeah, negative 22. All right. 3 times 7 is 21. And 21 plus 8 is 29, which is definitely not the same thing as negative 22. So, you're gone. Okay, next one. Let's try negative 10. So 3 times negative 10 is negative 30. And then we get, oh my goodness, would you look at that? My stars, it checks out. All right. So we got ourselves a keeper. All right, last one. All right, do they equal? 3 times 2 is 6. And 6 plus 8 is 14, which is clearly not equal to negative 22. And then so that would be how you do it. Okay. Okay, so now that's the introduction to solving an equation with variables on the same side. Okay, so this is all about what's called like terms. It's very Valley talk. Okay, very Southern California Valley talk. So I've got 14 yaks, and I'm going to subtract from that 7 yaks. So that leaves me 7 yaks, because who doesn't like a good yak? Okay, now we have an equation that's like what we were just doing a few moments ago. We said, oh, well, what's being done to the variable? Well, we're multiplying it by 7. What's the opposite of multiplying by 7? I don't know, dividing by 7? Oh, that's right, and those can cancel. And I have to, whatever I do to one side, I have to do it to the other. And then that way it stays in balance, like a scale. Okay? Whatever you do to one side of an equation, you have to do to the other. And so like an old-fashioned scale, that way everything stays in balance. If I'm going to throw in put a divide by 7 on one side, I have to do a divide by 7 on the other side. Okay. How about one more then? Because doggone, that was fun. Alrighty, so 10W. So I got 10. Well, what's a good thing that starts with W? Watermelons. 10 watermelons, and I subtract away 6 watermelons. Okay, these guys, I can combine them because they are like terms. Like terms are terms that have the exact same collection of variables. They both have exactly 1 W. So I can combine them. So 10 watermelons minus 6 watermelons would be 4 watermelons. And then I say, now that I've got, this stuff simplified, what's being done to the variable? Well, it's being multiplied by 4. What's the opposite of multiplying by 4? Dividing by 4. Silly goose. And 4 divided by 4 is 1. Now, if there was no W here, then I would say I wouldn't be able to combine these two. I'd have to do something different that we have not yet covered. But yeah, because these would no longer be like terms, because they would not have the exact same collection of variables. Okay, because this one's got a W and this one doesn't have any variable. Or if we had something like that, we'd say, nope, they're not like terms. This one has a W, and this one has a W squared. They're not like terms, and I cannot combine them. Now, we will not get to problems like this until Math 70. Okay. So that's how it goes. All right, so multiplicative property of equality, same thing, but with fractions. Okay, so we've got 35. I'm just going to write it over here just so I have more room to work. Okay, so, whoops, wrong button. Doggone it. Okay, so I would say, all right, I've got an equation. I want to solve for the variable because that's what's going to bring joy and happiness to my heart. And so what's being done to the variable? It's being multiplied by 5 halves. What's the opposite of multiplying by 5 halves? Oh yeah, dividing by 5 halves. And anything divided by itself is 1 or cancels. And if I divide by 5 halves on the right, I need to divide by 5 halves on the left. Okay. So on the right, we just get y. And on the left, we've got 35 divided by 5 halves. Huh. Wait a minute. We've seen how to handle that. We can flip the second number, which makes it multiplication. And then I will slap a 1 underneath this guy. And then I can also say, oh, check it out. Now that it's multiplication, I can cancel stuff where applicable. 5 divides in once and 7 times. So 7 times 2 is 14. 1 times 1 is 1, or it's just 14 for the answer. Okay. This is starting to get a little more interesting, especially with these fractions. It's all based on stuff that you've seen in the past, but now you're having to start to put more and more previously learned knowledge together into a single problem. Okay, so that's so you're going to definitely want to practice this a number of times and over a period of time. All right, new one. Okay, so it's the exact same thing, except now you got a sign, a negative sign sometimes. Not a big deal. All right, so let's do it over here. So 28 equals negative 7/5 x. And I say, all right, well, what's being done to the variable? It's being multiplied by negative 7/5. All right, well, what's the opposite of that? Dividing by negative 7/5. Okay, cool. So, whoa, I didn't do that very well. Those guys cancel. Okay. And we're just going to get x on the right side. On the left, we've got 28 divided by negative 7/5. Okay, so I can turn that into multiplication and flip the second one. Whoops, already got an x over here. I don't want to use an x right here. Okay, I'm going to use a dot. And then I can say, well, I can 7 divides in once and 4 times. Okay, so 4 times negative 5 is negative 20. And 1 times 1 is 1, or just negative 20 for the answer. So you do the same thing. It's just one number is negative, but that doesn't really change anything in a meaningful way. All right, last one. Martina is saving money to buy a game. Okay, probably Monopoly. That's what everybody buys. And let's see. So far she has saved $30, which is 5/6 of the total cost of the game. How much does the game cost? Well, let's think of it this way. First of all, it sounds like she has not yet saved all the money. So the game is going to cost more than $30. So our answer better be more than $30. But she's already saved up 5/6. Well, 6/6 would be one whole game. So 5/6 is, she's almost there. Okay. So the answer shouldn't be much more than $30. And this is, part of what you do with word problems. You just kind of say, all right, well, what would make sense? Instead of just, I need to do equations. No, just sit back, think about it, pretend it's your actual life, and don't even think about algebra at first. Okay. All righty. So now what do? We know the answer is a little more than 30 bucks. What is the answer? Or how much does this game cost? Okay, well, in a word problem, typically when variables come into play, it tends to work better if we define our variable. And this is going to be the case always whenever you see a word problem. This class, the next, and the next, and the next. Okay, so I'm going to say G for game. Okay, so G is my variable. You can call it Q or X or whatever. I don't care. Doesn't matter. So G equals price of the game. Okay. Now, notice I didn't just say G equals game, which is what a lot of people want to do. Okay. Because why didn't I do that? Well, because that's a little bit ambiguous. I don't want the math to be any harder than it has to be. I want it to be easier. I want to know exactly what G represents. Okay. And so, oh, nuts. So let's see. Is it? Oh, it's not going to let me do that. Let's see. How do I click back on it? There we go. All right. So I want to do this. Like, oh, price of the game. If you want to be more specific, you can say price of Martina's game. But Martina's the only one of the problems. So I'm pretty sure that omitting her name right here is not going to make the math any harder. Okay. So it said the problem says that 5/6. Where's my little thing? Okay, 5/6 of the cost of the game is $30. Okay, or yeah. So let's just write that down. 5/6 of the cost of the game, price of the game, is $30. That's is. This is exactly what you and I already understood beforehand, before we were even thinking about algebra. It was like, yeah, 30 bucks. Yeah, that's 5/6 of the price of the game. Okay. And now we're just practicing writing it as an equation some more. So 5/6 of the price of the game is $30. All right. So what's being done to the variable? Well, it's being multiplied by 5/6. What's the opposite? Dividing by 5/6. Okay. So those cancel. And we're going to get G on the left. And on the right, we get 30 over 1. I'm going to change this division to multiplication. Okay. And flip that second fraction. You'll notice I skipped one step because I've already done a bunch of these with you. And I notice that 5 divides in once and 6 times. And so, whoops. 6 times 6 is $36. And that's consistent with what we expected. We expected the answer to be a little bit more than $30. Okay, notice I didn't get a negative number or $500 or $80 or anything. Okay, just $36, which makes sense. I love word problems. One of these could very well be on the test. Feel free to go practice this over and over and over. Okay, a whole bunch.